Hi. Today we're going to be working with the Hi. Today we're going to be working with the logarithm. The logarithm is the inverse function of the exponential function, right? So the definition of logarithm is base b for positive number x satisfy the following definition. For b greater than 0, first of all, we're seeing that the base has to be greater than 0 and cannot be equal to 1. We have that the logarithm base b of x equals y. If and only if we raise that b to an exponent y, and that equals x. So the solution of the logarithm is an exponent. So we're going to see how to change an exponent form to a logarithm form. Okay? So in this case, I have the logarithm of base 6, right? Because my base on this exponent form is 6 of 36 equals the exponent. Again, logarithm of base 6. Now we're going to put the power, the solution of the power. So 36 equals the exponent, right? So for example, on the second one, I have logarithm of base 2/3. Again, that's the base. The solution right here, 8 over 27 equals 3. So number 3, again, logarithm of base 3 of 1 equals 0. Here we can see a property that we're going to be studying that properly later on. Okay. On the last one, number 4, my base is 10. When we are working with logarithm, logarithm of base 10 is the basic one. So that means that we do not need to write that base equals 4. So again, when we have a base of 10, we do not need to write that base right here. So logarithm of 10,000 equals 4. Okay. If you look at your calculator, you should see that sign without the base. I'm going to show you later how to change any base form and use your calculator to solve it. Okay. So the second part, now I'm going to go the other way, right? So as you can see, I have the logarithm. Now I'm going to write the exponential form. So that means that, again, the base right here is 9, the exponent is 2, and 9 squared is 81. Okay. Again, number 8, I have my base is 2, my exponent is negative 6 equals 164. Right? On number 9, again, my base is 3, my exponent is 5, that equals to 43. On number 10, again, as you can see, I don't have a base there. So that means that my base is 10. Negative 2 equals 1 over 100. And I have all of them in exponential form. Now I'm going to use that information of the logarithm to solve some exercise to find the solution of the part that I'm missing. As you can see right now, I'm missing the exponent. So I'm looking, let's write this as logarithm of base 5 of 135 equals x. So that means that I'm looking what number I raise 5 that equals to 125. Right? I'm going to use this operation right here. So I'm going to look at 5 to what exponent. In this case, as we know, is 3 equals 125. So 5 cubed equals 125. And as you can see right here, my bases are the same. The only way that those two powers are the same is that the exponents are the same. So in this case, that means that x equals 3. So logarithm of base 5 of 125 equals 3. Right? Number 12, again, let's write x. I have 4x equals 32, right? There's nothing that I can raise 4 that give me 32. But I maybe can check if I can change both bases to see if could have the same base as I did on number 11, right? So in this case, for example, I can change 4 to 2 square x, and 32, I can write it as, so 32, I can write it as 2 fifths, right? Property of exponent tell me that if I have a power raised to an exponent, I multiply those powers. I'm not adding or subtracting, I'm multiplying those two powers. So that means that I have 2x equals 2 to the fifth. And now that I have my bases are the same, that means that the exponents has to be the same. So 2x has to equal 5. And now I'm just dividing by 2. So x equals 5 over 2. So now we are going to continue the same, right? We are going to change this to a exponential. So 64x equals 1 over 32. Again, in this case, I don't have anything that I can raise 64. That give me 1 over 32, but I'm going to rewrite this as a power of 2. So 2 to the 6 times x equals 2 to the negative 5. Again, remember that negative sign, this is just property as exponent. That negative sign means the reciprocal of that fraction. So 2 to the negative 5 equals 1 over 32. 2 to the 6 equals 64. So now I just have to equal the exponent. Negative 5, 6, and 6. So that means that x equals negative 1, negative 5 over 6. So number 14. Okay, so number 14, again, we don't have the base, so that means that I'm going to pass 10 to the x equals 0.001. 0.001 I can express as 10 to the negative 3, right? Because this 0.001 is the same as 1 over 1,000. So that's the same as 10 to the negative 3. So I just need to equal the exponent, so x equals negative 3. And that's it. Now number 15, again, I'm going to equal that to x. So a to the x equals 1. And we know as property of exponent that anything that you raise to 0 equals 1. So that means that x equals 0. Now, number 16, this is a little bit different, right? Because we can see that now we have the exponent. We're just missing the power. So x equals the base to the third. So in this case, this is just 64. That's it. On number 17, again, I have x equals 7 negative 2. So x equals 1 over 7 squared, that is 49. And number 18, I have x equals 4 to 1/2. And as we remember as rational exponent, that's the square root of 4. So this is just 2.